but let's see how things are looking here. The green screen is a little bit funky. Let's see if I could fix that before I switch over. Chroma key. Yeah, I set this all up yesterday when it was afternoon and the windows are open. So now I have to fix you. Okay, that's a little bit better. Yeah, let's try that. And transition. All right, so that's looking good. For the main, display capture is off. So let's turn you on. And I think that's good. Right, there's no hide here. Just minimize. So today, the plan that I have is to see how well GGEZ worked with this computer. Specifically, how many particles we can get on a screen, because this was something that we were running into trouble with the Linux computer. It was just having a lot of trouble. Now, a big part of that is because it's a laptop, not because it's a because it was Linux. So I figure let's just give this Windows computer its due. Let's see how well it does. So I've already created a cargo sort of project for us. Called it stress test here. We compiled some Rust code yesterday and it worked. So, you know, that was really cool. Let's see if I want to do, I need to cd into it. Cargo run. So this isn't the Windows side. This is, I guess it's the PowerShell. And if I run that, okay, hello world. So we want to set up, get the basics of GGEZ going. So if I don't have some stuff that is in here. What do I want? I am going to want Rust, so RLS. I've tried Rust Analyzer in the past, and I think I'm going to wait until it's a little bit closer to release for them. Not everything that I wanted to have expanded out or auto-completed was auto-completing, which was making it a little bit annoying for myself. So RLS is still going to be the one I go to right now, but I am keeping my eye on it. It's a really cool looking project. And I think there was a cargo.toml. Yes, okay, so crates. I think that's what it was. So if I do that, then we open up cargo.toml and we can do, I want GGEZ. Save you, right, and you give me the latest, which is 051, so I gotta do that. Let's not use BBGGEZ for this one. We'll just do like pretty pure and simple. I don't have any of my snippets installed though. So RLS not installed. Yes, go ahead and install that. While that's working, let's go find. Let's see. This is going to be. Hey, don't do that. You just do whatever I want you to do. Okay, so I wanted to go to github.com/GGEZ. And then we'll grab the examples here. So we have our function main. Thank you for letting me know that there's updates. I'm not going to install them right this second. All right, so we have our main. I guess we have to do our struct my game first. So this is the first question. Can you hear the fan? Maybe. It's a little bit hard to tell. But still at 60 frames per second. Still looking good there. Wait a second. Did I didn't bring in the main screen. That's a problem. Also, I'm sort of disappearing with that. So that's gotta fix that. The fun joys of playing with a new computer. So I think that works better. Yeah, okay, I'm not fading out anymore. All right, back to you. All right, so we're gonna create a struct and then we're gonna implement these two things. So I'm gonna go ahead and copy you. Back to this code, create a new file. We're gonna call this lib.rs. Paste you in here. So first of all, this is just me. I like to call this context and actually spell it out. This is all fine, but it's going to be yelling at me. Let's see, did it install? I think it did. So if I save you, are you going to start yelling at me? Because I haven't like used any of these. No problems yet. Let's try restarting the RLS. Nope, not extensions. Oh, there it goes. All right, yeah, we need to bring in context. Let's use ggz. We'll just bring in context first. All right, we also need to bring in game result. And event handler. And graphics. All right, so that gives us all of this. That's fine. I can underscore you to make the context go away. And in main, we're gonna have to extern create use. We called this stress test, I believe. Yeah, just stress dash test. Okay, so extern create stress dash test, and then use stress test. Oh, do you not like that name? I'm gonna have to change it to underscore. And then this should give us my game. I believe we should get out of there. Oh, struct my game is private. So let's make that public. All right, perfect. Let's go get the rest of the main function, which is right here. All right, so we make the context. So we need the context builder. So let's start bringing in stuff that we need. ggz, context builder, and event. And I think that's all we need to get things going. So at this point in time, I should be able to do cargo run. Oh man, that fast compile. And while we're looking at that, CPU is not peaking at all. 60 frames per second, no drop frames. That's what I like to see. it was at this point that we went down to around like 1 frame per second on the Linux laptop. But I have enough cores and memory on this system that it can handle that. All right. We're able to get our window here. So let's go ahead and come back into live.rs. We're going to sort of begin setting this up. So to begin with, let's actually clear this to be black. So a black background. And I'm thinking we're just going to have maybe stuff starting in like the bottom of the screen and just like shooting up sparks everywhere. And then they hit gravity and they come back down. So that means we need probably like a spark or a mover or something like that. Let's create a new file. I'm going to call this, I haven't played with capitalization named files in the past. Because I do wonder if I want to like treat them like classes, sort of like, okay, this will be a mover with a capital M.rs. I don't think I'm going to do that right this second, but I'm going to maybe take a look at that later. All right, so we have our mover class. This is going to be our, I'm going to rename it to be like a spark. All right, so we're going to have a pub struct spark. We know that we're going to need a location. Now the location we're going to want to be a vector2 because it's going to be easy to do some physics stuff with that. So let's see. We're going to want to bring in, so use ggez and algebra vector2. So you're going to be a vector2 of f32. What else do we know that we're going to need? I guess we could start right here with this. And we're going to implement Spark. All right, so pub function new. So when creating a new Spark, I don't know, well, we know exactly where to put it. So let's take in the location. So location is going to be a vector2, f32. We're going to return a spark. And so all we're going to do is return a spark with location in it. So if I save you, then I can pull it in here. So we're going to say mod spark use spark, and now we want to maybe save our spark. So we probably want like a vector of sparks. So I'll just create a vec of sparks. I'm just going to type vec that holds a spark. All right, so in here we know we're gonna need an algebra. So use ggez and algebra vector2, and we know we're going to need to create a location for this spark. So let's do let spark equals spark new. Our locations, that's going to be a vector2. And then the location, let's just do something like 50 right, or I guess for you it would be 50 right, 50 down. And then we're going to load this into a vec and put a spark in it. Oh, sparks. All right, perfect. So that gives us our new our spark. We're gonna need a we're gonna need some kind of like graphic to represent it. So that's gonna be, I think we're gonna have the equivalent of a like a static method on here. So we're gonna call this create mesh. And I don't know if I necessarily need to hold this, but we're gonna have to return a use ggez a game result. We're also gonna use the graphics. Simply because we're gonna need like the mesh and stuff on it. So let's go ahead and use those two. ggez, we want graphics. So a mesh and a mesh builder. Then in here, we're gonna return a game result of type mesh. Okay, so to create our mesh, I'm thinking just a circle. Maybe of a random color, but for right now, let's just make them all one color. I guess that means we do need a color here too. So graphics, color. All right, so let's do, we're gonna return a mesh builder, new, dot, let's make it a circle. Mode, right, we need a draw mode. So draw mode, we'll do this as a fill. Point, so the location of where this is. So not just a vector 2, we need a point 2 as well. And let's, I always like to make these 0.0, and then we're gonna translate it into the correct place when we draw it to the screen. That way we can just use this one mesh and reuse the mesh over and over and over again. Our radius. How big do we want this to be? Let's just hard code it to something like 5. Our tolerance, how much like a circle do we want it to be? I can do something like 2.0 and it'll make it very diamond-like, or at least not like a true circle. And our color. So we need to create a color for this. I'm thinking, so color, new. All right, so it wants RGB between 0 and 1. It doesn't have hue. So if I make these all red, let's say, there'll be 1.0, 0.0, 0.0, and 1.0 for the alpha. And then dot build. And oh, we need to bring in the context. All right, so then we're gonna have our context and then return whatever build returns, which is already a game result of mesh. So this allows us to now run the create mesh and store it in here, which means we're gonna need use ggez graphics mesh. So this is going to be a Spark mesh. We're just going to store it as a mesh in here. And all right, Spark mesh. All right, well, Spark create mesh, pass it in the mutable reference to the context. Don't hit the Windows key. All right, so what are you upset about? Oh, mismatch types. So at this point, I want to do a question mark. Now, if I want to do a question mark, that means I can no longer do my game like this, which means that I'm gonna have to do a game result around my game. So game result, my game. Expected enum result found struct my game. Oh, right. Now that means if this is good, I need to wrap this in an OK. Of course, this causes a problem over in main RS. We need to handle this. So when we get my game, we're going to just do an unwrap. So crash if that fails. All right, so we have our mesh. Where is Spark? No, LibRS, that's what we care about. So we have the mesh. We're not going to do anything with update. Let's go ahead and draw this to the screen. So we're going to have to loop through all of our sparks. So for spark in self.sparks, and I'm going to want to have this be a reference so it doesn't yell at us about moving out of the vector, because I don't actually want to do that. Then for all these sparks, I want to draw it, right? Now I have the mesh here. I don't know if you heard that. That was my Discord, not yours. I remember Discord, I had at one point in time hooked it up to my Twitch so it would go into streaming mode whenever I started streaming, and then it wouldn't do that. All right, let's see. Function draw, so for spark and self.sparks. Now let's go ahead and draw this to the screen. So we're gonna do graphics. I think it's just draw. The context. Oh, I want you to be context like that. Context are drawable. So this is the mesh. So we're gonna do self spark mesh, and then the params. This is where we can send it to a completely different location. So we need to draw params in here. Draw param, and then in here we can do draw param. We want the default draw params, but we want to override the destination with a new point. So here's where we can maybe say like, hey, the Spark, let's have a function that exports your current location as a point too. So we'll do pub function, and this is, what are we gonna call it? Export location, or maybe location as point. Okay, I could also just do pub function location as sort of like a lens into what this location is. So you don't directly get it, you get it through this function. We do need just a reference to self, and that's it. And we're going to return a 0.2 of F32 back. And so all we're gonna do is return let's see, 0.2 new self.location.x self.location.y. So it will have to create this 0.2 every single frame. We'll see how that ends up working out. So pub the location. So our destination is now going to be spark dot location, and that gives us the actual location there. And then we want to question mark this for the draw and semicolon for the end. Context. So that should get us something on the screen. Let's test that. It's been a while since we compiled this. There we go. So we got sort of a diamond-shaped little Sparky over there in the middle of the screen. All right. Let's go ahead and now put the spark maybe in the middle of the screen at the very bottom. In our My Game here, we can figure out where that is. We're going to need to get the actual size, the arena size. So let arena width, arena height equals. So this is off of graphics drawable size. And we pass in the context. And then when we give the location for this, our location is going to be half of the width. So the arena width divided by 2.0. And then I want it to be the entire height. So arena height. Okay, so that gives us our spark is now going to be in the middle and the bottom. There that is. We want to give it a sort of like a push, so it starts moving up. That means we need some kind of like force system, or at least we're gonna need a force system because we're gonna want gravity also eventually. So let's go ahead and set that up inside of Sparks. So we're gonna have location. We also want a velocity. This is a vector 2 of F32s. Alongside of velocity, we want an acceleration. There's also a vector 2 of F32s. So velocity and acceleration. Is there anything else that I need for that? I don't necessarily think so. So we need some kind of like update. So pub function update is going to be taken mutable self. I don't think we need to return anything necessarily. All we're going to do here is we're going to take the location. Take the velocity. So we're going to say self.velocity plus equals self.acceleration. Then self.location plus equals self.velocity. And then I need to reset the acceleration. So self.acceleration multiply equal 0.0. So that way it just resets. And that should be our update. We're probably going to want to do something with delta time, because I can imagine this is like just going to move way too fast. But I keep on running into problems of like, where do I apply the delta time? Am I going to apply that like here, or when I add each individual like force in? I never quite remember. So then it's going to be apply force. So pub function apply force. So mutable self, and then we want force, which is going to be a vector 2 F32. Again, we're not going to return anything. If the function runs, we're good. So here we're going to say self.acceleration plus equals to the force. And that's it. So the apply force will make it move up, and the update will actually make it move on the screen. We'll update the location. So in the library, let's have maybe like a constant for, or like our initial force up. Initial up force. And so we know this is going to have to be a vector 2 of type F32. All right, our initial up force, vector 2, new. Let's say that this will be like a negative 5.0 and 0.0. I just want, actually that's sideways. 0.0 and negative 5.0. So it just goes straight up, and that's kind of it. Bringing in a random to like make it go random directions, I think that would be what I really want to do. But for right now, let's just do this. So our initial force is up. On update, oh, you know what? We want to, I don't actually know if I need to store this, do I? My initial force is actually just going to be applied. So let initial force equals this vector 2 new. And then I'm going to say spark dot apply force initial force up. There. Now it's going to be wanting to go up. In update, we're now going to run, so we need our for loop. So for spark in self dot sparks. We're going to say, oh, and this has to be mutable. All right, so spark dot, I think it's just update. Run that, and now we should see the spark sort of disappear off the top of the screen. Let's see, what am I missing? Missing acceleration and velocity in this spark. Oh yeah, I didn't actually set our velocity and acceleration, so let's go ahead and do that here. So our velocity, vector 2, new. We're gonna begin with just 0.0 and 0.0. And you are an acceleration. So that way it begins not doing anything at all. Cannot borrow as mutable. That is not declared as mutable. Where is that? So in Spark. Oh, let's Spark. Okay, in here, you need to be mutable. There's our initial our initial push, and it like pushes it, pushes it up, and that's all good. Okay, so now I want it to be going up in random directions. So in a random direction, I would have it, well, we're gonna need to bring in rand, aren't we? What? You didn't find this? Is it not? Oh, it's called rand, isn't it? Creates.io. Yeah, rand is still the most downloaded. Yeah, it's totally rand. I don't know why this isn't doing its thing. Save view. All right, so in our main library, for our initial force up, we're gonna want to now use rand, the prelude star, so bring in all of those things. So let RNG, it has to be mutable. equals rand, I think it's thread range. And now for our new here, we can now do an RNG dot gen range. Yep, okay, so that's right. Our gen range, so let's say we want it to go between like left, so negative 5.0 and 5.0 for left and right, and then up is going to be constant. So we can even make this a little bit faster than what we had. So let's do like negative 7. So that will be now going like off in the random direction. And so if I save you and run you, now it will not be going straight up. Yeah, it goes off at a like fun angle. Let's create a function in here. So this is gonna be a private function that creates a spark. So create spark. This could be a mute self, maybe. Let's try it out. So if I create a spark and I want to just push it into the sparks vector. So if I don't return anything, I actually want to just create the spark. And do that here, essentially. In fact, all this wants to be done in here. Our initial up force also wants to happen in here. And then our sparks is going to be an empty vector. All right, so we're random number generator. We get the arena height. We create the spark, we create the initial up force, we apply the spark to the up force, and then we're gonna say, we need context here. And then we're gonna want to put that into, put this into the vector. So self dot sparks dot push our spark. All right, so now if I call this on update, so every single frame we create a new one. So self dot create spark, pass it in the context. Now, what are you upset about? Oh, cannot borrow self as mutable more than once. Okay, so I can't actually do the push here. I'm gonna have to do the push down here. Oh, and I'm not gonna wanna use you up there. Oh, this works. Self dot sparks dot push spark. Yeah, I don't want to put it in the for loop. I wanted it before the for loop. So create the spark and then update them. So if we run this, we won't be able to run it for too long because we have no way of like removing sparks at this time. But it's able to create so many of them. Now, in the previous computer, this was slowing down already, and I don't see any hint of it slowing down at this point. We are creating tons and tons of entities. There it goes. Now it's starting to slow down. And we're not having any of them sort of disappear or die. Let's create a gravity and have that apply to it. So we're going to want a gravity. And that's going to be a type vector2. So let gravity. So vector2 new. the X doesn't get applied, and then just the Y. So I'm probably gonna want something like maybe a 5.0. I don't know, I'm sort of making that up. We'll add it in here. Gravity gets added in. Now we can, on every update, before we update the spark, we're gonna say spark.apply force, and we're gonna hand it self.gravity. Now this will make them fall down. That's maybe a little bit too much. It can't actually get out. It doesn't have enough to like escape. So that's cool. Let's maybe not make it. Let's just try 1. It's a rather sad looking fountain there. Maybe something a lot smaller, like 0.1. There we go. That looks a lot better. So now that I have the gravity working, I'm gonna want to kill them as soon as they go off the screen. So when they go off the screen, let's go ahead and mark them as deleted, and we need to remove them from the vector. And this is where it gets a little bit interesting. Our other choice is to recycle them and just like reuse them as soon as they go off the screen. That might be interesting too. Because what I could do is create, let's do that. Let's create them as long as the average frame rate is above 60. So here we're on update. Let's get the average frame rate. So that's using the timer. Let's use GGEZ, timer. Yeah, the and update. So let I think I can do average like frame rate. All right, so we have average delta. Check update time, the actual delta. Is there just a frame rate? Let's go into the documentation for GGEZ. So I want the frame rate. How about FPS? Okay, so there is FPS of the game averaged over the last 200 frames. Okay, perfect. So I can just do pub function FPS. There you go. FPS, hand it the context, and this gives us the average frame rate over the last 200 frames. So in here we can say if the frame rate, if that is greater than 60, then let's go ahead and create a spark. Now this will drop us down below 60 because it's the average, right? So we'll probably go to like 50, 58, 50, 55 or so. But at least we're gonna cap the number of them that we create. So if I do this, let's see how long it runs before it just stops. Oh, wait, is this oh, it's an F, 60.0. For some reason, I saw it as like a U. As long as it's over 60, it didn't create any of them. Let's see what our frame rate is. Let's actually draw that out. So if I'm gonna need to create the actual text for drawing. So we already know that we have the frame rate. So I guess let's grab that. So frame rate equals timer FPS. Pass it to context. We're gonna want the actual text to draw. So let FPS text equals, this is going to be off of graphics. We're going to have a text new. We're going to have to put a format. And in here, we can say, okay, FPS colon. And then use the frame rate in there. And then we want to draw this out. So then it's going to be graphics draw. Pass it in the context. The drawable is going to be this FPS text. And then the draw params. So draw param, default. Okay, so we need our destination. So this is going to be a point to new. Did I bring point to in? I did not. Let's bring this like just top left. So maybe like 5 right, 5 down. And question mark. So I think this should give us our FPS counter. Ooh, our FPS is really slow here. That's the reason why. Now if I don't have this check here, if I basically get rid of that, save. Let's see what everything looks like. It's nice and smooth as I'm creating it, and if FPS isn't really being hit, in fact, it's going up. But that's that. So that's the frames per second. Okay, now it's dropping quite significantly. I'm curious, what if I run this in release mode? It does have to recompile all of this. But I'm wondering if I'm getting some kind of, it's not like nice to the processor. Because I do remember on the Linux computer, we were able to get really good frames per second, but it would eventually just hit the CPU and destroy it. So I wonder if there's something I need to do to like tell it, okay, you can use the entire CPU. I wonder if Windows is trying to block us a little bit. I don't know, it's a little bit hard to predict there. Still around 30 frames per second. And it's able to hang out there for a while as it's creating all these meshes. I guess I suppose I could have this be 30. So if this is greater than 30, let's go ahead and create the spark. Giabel, good morning. Interesting how it like spins up to do that. What am I doing today? I am stress testing the this new Windows build that I have, desktop, to see like how it works when I'm creating so many entities. And it's interesting. Not I, but we. It's interesting because it's able to handle a lot more. It compiles really, really, really fast. I am capped, like my frames per second is capped though. Which I think is interesting because I'm not getting that on the other like Linux computer that I was using for streaming beforehand. So I am it's a little bit weird / concerning. Is this just a standard computer? Yeah, it's a standard desktop computer that I got. And the program, well, I just made the program live. It's using Rust and GGEZ. And I'm basically creating these entities and sending them up as sort of a stream of fountain. GGEZ, yeah, it's a it is a game library for Rust. Or I guess a framework. It's a game framework for Rust. We're able to stay on 30 frames per second, creating a huge number of these entities, like way more than we were ever able to on the Linux computer. So I mean, there's that. Like that's a good thing. It's just the weird like spin up. What do I mainly program? I don't necessarily program games. I guess a lot of it is the visualizations like this. And then the main thing that I've been working on recently is learning game development programming patterns. And so I'm going to be getting back into that as soon as we've got this desktop computer all set up and working properly. Well, I mean, this is both like really good and sort of questionable. I wonder if there's like a profiler that I can add into like to Rust to give it access to more CPUs or more. I also wonder, is this using the graphics card at all? Probably not, because I'm not like the meshes is not really doing anything hard whatsoever. I'm just creating a single mesh and sharing it over and over again. So like all of these is just one mesh. That's not really going to tax the graphics card. No physics library. I programmed that myself today. It's a really simple, just sort of like some vectors to hold the location, the velocity, the acceleration. I'm just giving an initial acceleration up and then applying gravity to it. Let's find a program to find GPU usage. Yeah, I would like to, but I am going to have to end the stream pretty soon because I need to go to work. And go to work these days is really just me switching over so that I can work on work stuff. And that's coming, like my stand-up is coming up pretty soon. That being said, like, I don't know. You're working right this second? Yeah, they would notice if I'm streaming while I'm working. And it's a completely different computer too. Hey, that might be a little bit too much. All right. Well, regardless, part of the stress test, yep, exactly. Part of the stress test is successful. We're able to get way more entities being created. I'm not deleting them when they go off the screen. Those are continuing to update as they fall down forever. In fact, I'm assuming that eventually we're going to it's going to crash the computer by getting an underflow, where actually it would be overflow, right? Because the F number for the floating point number for the location is eventually going to go so high in the Ys that it's just going to, crash. That hasn't happened yet, which lets me know that, I mean, I guess that's interesting. I could have it probably like stop and recycle them or do something else. Versus my other computer, absolutely yes. It is an older computer. It was an older laptop that we were using. So I'm very happy about this part. The frames per second being capped at 30, that's not quite as awesome. And I might have to do a little bit of research to figure out where, what I can do to potentially like increase that. So that way I'm just like using as much as possible. Maybe there's something in GGEZ where I can like tell it, hey, don't cap my framework. Maybe they're not capping it and that's just my processors. Where's my specs? Oh, I don't have that set up right now. The old laptop is a Dell, it's a several-year-old Dell computer that's running Linux. But regardless, I think this part is successful. So with that, I am going to end the stream. I am not going to run that right now. I'll think about that. But yeah, time to get back to work. So thank you, Giabel. I know that you just came here, but I will be getting back to it soon. I'll be switching over to my ending, my lovely handwritten ending screen, because I just sort of set up OBS for this recently. Physics, yes, it is cool to see Rust back. I am so happy to be able to do that. We're gonna be like eventually creating better transition scenes and everything else, probably doing some art with GGEZ and then recreating these. But regardless, everyone, thank you so much for stopping by. I hope that you have a great day. I'm gonna be trying to stream every day that I can like get up early enough that I can stream before work. And so with that, I hope that you have a great day. Follow me on Twitch. Follow me on Twitter for updates for when I go live. And with that, I'll see you next time. And I am not going to be working until 3 a.m. Thanks for the suggestion, though. All right, I'm leaving for real now. See ya.